Hello students, welcome to Saurav sir's classes. The question is, let x and y be independent binomial 3, 1 by 3 random variables. Therefore, x, y follow binomial with n is equal to 3 and p is equal to 1 by 3 random variables. Then the probability that the matrix P is orthogonal is, now for an orthogonal matrix, P transpose is equal to P transpose P is equal to I, where I is a unitary matrix. So over here, x by root 2, y by root 2, minus 1 by root 2, 1 by root 2, and then we'll take the transpose of this matrix. So this is x by root 2 and y by root 2 comes over here below x by root 2, again minus 1 by root 2, 1 by root 2 is equal to 1 0 0 1. Thus from here we get x squared plus y squared by 2 minus x by 2 plus y by 2 minus x by 2 plus y by 2 and half plus half is equal to 1 0 0 1. Thus the matrix will be orthogonal only if x squared plus y squared by 2 is equal to 1 and minus x by 2 plus y by 2 is equal to 0. So on solving this, we get x is equal to y, and putting this value over here we get 2x squared is equal to 2 is equal to x is equal to plus minus 1. But since x and y are following binomial random variable, it cannot take the negative values and thus it would only be plus 1. So using these two conditions, the matrix will be orthogonal only if probability x is equal to 1 and y is equal to 1. So once we find out this probability, we'll get the probability that our matrix is orthogonal. So 3c1 into 1 by 3 1 minus 1 by 3 squared into 3c1 1 by 3 1 minus half squared. We get this as 3 into 1 by 3 into 4 by 9, 3 into 1 by 3 into 4 by 9. So here we get this 3 cancels out. So we get 4 squared by 9 squared is equal to 16 by 81. Thus, the correct answer is option D. The next question is, let x1, x2, xn be a random sample from a population with the probability density function as fx, alpha is equal to 3 alpha x squared e to the power minus alpha x cube, where x is greater than 0 and alpha is greater than 0. Then we need to calculate the maximum likelihood estimator of alpha, that is MLE of alpha. So first let us calculate the likelihood function. So likelihood function L alpha is equal to pi I is equal to 1 to n f xi comma alpha. which is 3 to the power n alpha to the power n by xi squared I from 1 to n and e to the power minus alpha summation xi cube. Taking log on both sides, we get n log 3 plus n log alpha plus 2 summation log xi minus alpha summation xi cube. Now differentiating this with respect to alpha, we get del alpha is equal to n by alpha minus summation xi cube. And to calculate the MLE of alpha, we need to equate this thing to 0. So we get n by alpha is equal to summation xi cube. So alpha is equal to n by summation xi cube. Thus, the MLE is option A. Now for competitive exams, you can leave it up to this, but it is always a good habit to cross-check and see that the double derivative is less than 0, which confirms us that it is a maximum. So del 2 log L alpha del alpha 2 is equal to minus n by alpha squared, which is less than 0 since n is positive and alpha squared is positive 2. Therefore, alpha is equal to n by summation xi cube is the MLE.